All right, guys, moving on to Chapter 3, Lesson 3, Completing the Square. So in this lesson, you should be able to solve quadratic equations using square roots, solve them by completing the square, and apply completing the square to write quadratic functions in vertex form. So before we looked at these, we were able to solve them by getting it down to x squared. In this situation, we can't really do that, so we're going to rewrite this as a perfect square binomial. So I will show you what I mean by that. So we're going to start with this first one. So we're going to start with this first one. The first thing we're going to do is write the left side as a binomial squared. So what that means is I want something inside here that would be squared. So you could look at it as, what two numbers could you multiply to get 64 that would add to get negative 16? Well, first off, we know if we have a product that's positive and a sum that's negative, that means our term inside should be subtracting. So we're really looking for the square root of 64. We know the square root of 64 equals 8, and 8 plus 8 is 16. So because of that, we're able to say that the inside is x minus 8 squared. And we're going to keep the 100 on this side. We're not going to set this one equal to 0. Because now if we look at what happens, we can now do our next step. We want to get rid of the square. Well, how do we get rid of the square? By taking the square root. So as long as we take the square root of both sides, that square cancels out. It leaves us with x minus 8 equals plus or minus 10, because the square root of 100 is 10. So now we're just solving for x. We're going to add 8 to both sides, and we get x equals 8 plus or minus 10. Now, we can actually work this out, so we're not going to leave it that way. We're going to say x equals 8 plus 10, which is 18. And x equals 8 minus 10, which is negative 2. So those are our two solutions. So x equals 18 and x equals negative 2, those are our two solutions. So right now, if you want to give this one a try, on this lesson I put some extra ones on here. If you'd like to pause the video now and give this one a try, that would be a great way to see if you kind of have a little understanding. So if you would like to, please pause the video now. All right, so we're going to work this one out just like we did A. All right, we want a binomial inside. We want it to be squared, and it's still going to equal 81 on that side. So you're looking for, what's the square root of 121? Well, we know that's 11. Well, 11 plus 11 does equal 22. We have a minus sign and a plus sign, so that means inside we got x minus 11. So now you're going to work out the rest the same. So if you didn't already try this, please pause the video now and work out the rest of this problem. So hopefully you paused it and gave it a try. You should have got x is equal to 20 and x is equal to 2. So now we're going to move on to a part that's slightly different than how we've been doing this. So we're going to complete the square. So something to note, that we are going to complete the square for this expression. All right, so basically what we're doing is we're making a c value. So our c value is going to be made by taking the b value, dividing it by 2, and squaring it. All right, so that's kind of what we're doing right here. We're looking for the c value. So if you want to make a note that basically this b over 2 squared is your c value. All right, so let's get started. So this is the part that's called completing the square. We're going to use this part to help us in the future part with writing in vertex form. So this is going to help us with that. All right, so we have x squared plus 14. We want another value. So how do we find that value? So we're going to, in order to find our c value, we're going to take our b divided by 2 and square it. So that looks like 14 divided by 2 squared. Well, what is 14 divided by 2? 7. So we're squaring 7, which equals 49. So what does this become? we now have x squared plus 14x plus 49. And so now we can write that as a binomial. So this would be x plus 7 squared. So how do we know that? Because the square root of 49 is 7. 7 plus 7 is 14. Plus, think of it, we're taking this middle term and dividing it by 2. So that's kind of what this value, if you notice, these values are going to relate to each other. All right, so that's all we're doing right now. We are going to extend this in a little bit to help us to write in vertex form. So if you would like to, please give this a pause and try part B. So hopefully you gave this a try. This one is a little different because the 9 is an odd number. So in order to find our C value, we're going to take the 9 and divide it by 2 and then square it. We don't care about the sign in this situation right now because that sign's going to stay there. Your C value should be positive. So 9 divided by 2 squared is the same as 81 over 4. All right, and we're going to leave it like that just because it makes it easier when we write it in a binomial. So our trinomial would be x squared minus 9x plus 81 over 4. All right, I know it looks weird. I know there's a bunch of fraction haters out there, but I just wanted to show you that this isn't that bad. So now we have to turn it into a binomial. So remember how I pointed out the, I can't think of the word. Anyway, how these are the same? So we know we need x minus, and then this is our term for that. Because now if you set this up and did x minus 9 halves times x minus 9 halves, you would get that trinomial. All right, so this is kind of like backwards FOIL, backwards box method, but for perfect squares. All right, we're going to move on to example 3. Okay, so now we are going to do example 3. We're going to solve this when a is 1. So when our a value is 1, it makes our life a little easier. All right, so first thing we need to do is we are going to, so this is a little different than what we did. We want the left side to just be in the form x squared plus bx. I'm going to write that off to the side here. All right, so we want the left side to be in this form. So in order to do that, that means we need to move the 7 to the other side. So how do we move the 7 to the other side? We simply subtract it. So we're going to rewrite it as x squared minus 10x equals negative 7. Okay? So now we're going to do that completing the square part. All right, so we are going to rewrite this as x squared minus 10x, but we're going to have a value here. So because this is an equation, we can't make magic happen. So if we add something here, we also have to add it there. Why didn't we do that before? Because before we didn't have an equal sign. Now we do. All right, so we need to know what goes in here. So we know that we're going to take our b divided by 2 and square it. All right, so that's what's going to go in this box here. So our b is 10, so 10 divided by 2 squared gives us 5. 5 squared is 25. So that's what's going in on both of these sides. All right, why did we do that? Because now we can work on solving this because we can rewrite this as a binomial squared. All right, and then we combine our negative 7 with our 25 on this side, and we get 18. And so now we're to where we were in example 2. So now you're going to continue to solve this. All right, the way we're going to do that is we're going to take the square root of both sides. All right, we get x minus 5 equals plus or minus the square root of 18. I'm going to work out over here the square root of 18 so you know how I get to the next step. So we know this is the same as the square root of 9 times the square root of 2, and I can find the square root of 9. So square root of 18 is now going to be written as 3 square root of 2. All right, so we're going to add our 5 to both sides, and we have x equals 5 plus or minus 3 square root of 2. Now, I can't combine these because if this 5 doesn't have a square root of 2, they're not like terms, they cannot be added. So this is my answer. What does it mean? It means that my solutions are, I'm going to write them in a different color, x is equal to 5 plus 3 square root of 2, and x is equal to 5 minus 3 square root of 2. All right, so if you want to now try this with B, just to see if you kind of have an understanding, see if you get stuck anywhere, see if you need to ask some questions when you come into class next. I will go over it, but I would like for you to give it a little bit of a try. So please pause now and give it a try. All right, so hopefully you got to this part. Sorry about the people outside mowing the grass. I am at work and not at home, so you don't hear dogs today. There's a plus. So you should have added 4 to both sides because 4 divided by 2 squared equals 4. So if you didn't go past this, please pause now. I'm going to pause while they're mowing. Okay, so we aren't going to stop right here because even though there's no real solutions, in the last lesson we learned that there are imaginary solutions. So that's how we're going to work this. All right, so I'm going to rewrite this as x minus 2 equals plus or minus 2i, because the square root of 4 is 2, square root of a negative is I. And so now I can finish this by adding 2 to both sides, and I end up with x equals 2 plus or minus 2i. Now, you cannot combine these because they are not both i's. So you do end up with two solutions. One solution is x equals 2 plus 2i, and the other one is x equals 2 minus 2i. All right, so now we're going to look at one when a is not 1, so when a is a value other than 1. So we're going to give that a try now. All right, bells still go off during teacher planning days. So we are going to take our a value, and the first thing we are going to ask ourselves is, can we divide everything by that a value? And in this situation, we can. So that makes our life so much easier. So we're going to go through, and we have to divide every single term by 3. Why did I divide the 0 by 3? Because I want you to know that this side also gets divided by 3, because sometimes, like if you look at b, there's a number there. All right, so now we're going to go through and we're going to simplify it. So 3 divided by 3 gives us 1. 1x squared is x squared. 12 divided by 3 gives us 4, so we have 4x. And then we have plus 5 equals 0, because 0 divided by 3 is 0. So now I want you to pause the video because now it's the same as the example 3. So I'd like for you to pause the video now and give that a try. All right, so hopefully you got to this part. Notice our b value is positive, and all the other ones our b value have been negative. So because our b value is positive, this term inside is positive. So all I did was add 4 to both sides because 4 divided by 2 is 2. 2 squared gives us 4. So now I want you to finish working this out. So if you haven't already finished it, please pause now and finish it. All right, so the square root of -1, we know that is the definition of I, an imaginary number. So you should have got -2 plus I and -2 minus I as your solutions. All right, so this one is already moved to the other side, but the idea is still the same. You ask yourself, can you divide everything by 4? So if you can, go ahead and do that. Now, remember, we don't want that a value, so when it comes to completing the square, it should work out to where you can get rid of that a value. All right, so please, if not, it's usually when it's a perfect square. So just keep that in mind. Whatever goes inside your binomial has to be a perfect square. So please pause your video and give this a try. All right, so once you divided everything by 4, you should be at this part. So if you have not finished this, please pause and finish this part now. All right, so you should have gotten down to this, and then I just went ahead from there and turned it into I, subtract 4 from both sides, and we end up with this. So again, guys, if you have questions on any of these, the mower guy came back, just make a note and we can talk about it in class. The process does get the same. It just, you've noticed we've had one extra step at the beginning each time. But once we get down to this part, this is the same as what we were doing in example 1. All right, so I'm going to stop the video there just because we still have example 5 and the word problem left, and I don't want to jinx it and run over 20 minutes and the thing freak out on me. So I'm going to stop this one there and come back in the next video with example 5.